Alright, derivative graphs and continuity. Here's a big calculus question. Is yeah. That is a big question. Yes or no? Well, I haven't given you a function, so you can't say yes or no. A. Okay. What does this mean? Okay. Does it have a derivative? We've masked it. Same question. Okay. So if you see, is a differentiability is talking about functions having derivatives. Okay. This is where I'm going to use some general guidelines for functions that are not differentiable. Okay. Where there is a corner, which graphs have corners? Piecewise function, absolute value.
When it's talking about corner, does it mean like the entire function?
No, just a spot. We're talking a spot. So if you like this, there's a corner, not differentiable at x equals 0. It's differentiable everywhere else, right? But not at 0, because that's what a corner is. Okay? And we can also have cusps. What is a cusp? Have you ever heard that term? I think that'll work. What it has a cusp. So instead of this comes in straight, right? This one curves in. That's because of the cubic, or the cube root. So anything with a numerator, even power, denominator odd, is going to give you something like this. If that's not differentiable, x equals 0 again. Yeah, just in that one spot. I can take the derivative here, because it has a slope, right? And both sides are the same. So, what else? Oh, a vertical tangent line. That would be x to the 1/3 maybe. If you calculate the derivative there, it gives you a vertical not differentiable. The derivative is undefined. So that's the derivative of the power rule. It's the same as this. this would be, if x is 0, what is the slope? Well, undefined, right? So it gives you a vertical pendulum. We'll say it's not differentiable. The derivative is actually undefined at 0.
So I didn't find out where the classroom.
If there's an asymptote, it wouldn't cross it.
Oh,
It'll go up, and this one would come down. It would never cross it. Let's see. I think just about covers. Is f continuous in every one of these examples? Yeah. Yes, you can say yes, it's that easy of a question. Yes, f is continuous at 0 for every one of these, right? So, if f is continuous, does that mean it has a derivative? Okay, so. Just because it's continuous does not mean it has a derivative. Right? Question of the day? Well, yes, if it's differentiable, is it continuous? If I give you a point discontinuity, any discontinuity really, let's go to jump discontinuity. Is that differentiable at this x value? No. So if it's not continuous, it's not differentiable, right? But if it's differentiable, does that imply it's continuous? Does it have to be continuous? Yes.
I'm sorry. I have it and then now
I just gave you an example. It is not continuous. We can't take the derivative if that's true. Right? I've also given you examples where it's continuous, but we can't take derivatives.
Oh.
So the question is the other direction. If I have a derivative, does that apply if the f is continuous? The answer is yes. Okay. So keep that in mind. If f is differentiable, it's continuous. Okay.
And if it's not continuous, it's not different.
Right. Okay. So that would be, you have your 4 items that lead to not differentiable: corner, gust, vertical tangent, discontinuities. If I have a derivative, it does work the other direction for continuity. Okay. Keep that in your brain because you're going to need it for the how you do it. So consider what function is this? Yeah. Is it continuous? Sorry, does it have a derivative everywhere? It does. You can always find the slope of any tangent line. There are no corners, there are no cusps, there are no discontinuities, no vertical tangent lines. Okay? It's completely differentiable. And nothing causes it to be undivided. So because it's differentiable, we know it's continuous. Okay? So you can go back. What if okay, so we're going to switch gears to graphs. Graphs and derivatives. I'm going to draw a graph up here. Make this a 1. This is a 1. Let's say this is at 4 and 7. This could be a sine or cosine function. Could be. It would be a maybe negative sine x plus 1/2 or something of that nature. But I'm not worried about the function. Can you interpret the derivative graph of this? So this is f of x. Can we draw on here a derivative? Okay. What is, so remember, all we're looking at is what is the slope of f, right? So at 1, what's the slope of that? 0, right? So the derivative, if the slope is 0, right, at x equals 1, the slope is 0, the derivative has a point 1, 0. Right. So basically you're taking the x value and you're mapping the slope on your grid. So the slope is 0 here, right? So the derivative is going to have a point at 0.
Why isn't it another one?
We're going to draw that here. What is the derivative of 4? 0. So what's my point? 4, 0. Where else is there? 0. 7. Okay. Now, what happens between those points? What's the slope here? Positive or negative? Negative, right? So the graph of the derivative is going to be in the negatives. Okay. Slope of f is negative. Okay. So the derivative is negative. The value is below the x-axis. Below x-axis. Okay. What's happening here, though? It changes to positive, right? So where's my graph going to get a derivative? Up here. Right? Until what point does it go negative again? 4 it goes negative. Right? So I'm going to be back down here. So this is going to look something like this. Right? And negative, 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 right? Until 7, it comes back into the positives. There's the graph of my derivative. You're thinking slope values. This has a negative slope, right? So I am in the negative values below the x-axis. This has positive slope, so my values are above the x-axis for the derivative. Okay. Go ahead. Like the giant wave coming, a large section that's what the is, the black, and then black is actual wave. That is I don't know if that's about a good yet. Yeah, however. Yeah. That's, so people get confused with this. We're not actually figuring out the slope. We're not graphing the tangent lines. If I graph the tangent lines, it might look like this. Right? At any spot, those would be tangent lines. And what we're graphing is the value of that slope. So, yeah, so what's the slope here? 0. So we're going to put a dot at 0, at 1, 0. Okay, we're not actually saying that this is the tangent line. It's not a line, it's a curve. All this is mapping is the values of all these slopes throughout. Yes. Okay, so the slope of this one might be -2, right? Yeah. I don't know what it is, but it might be -2, so I'm going to put a point at -2. And here, this might be -2 again. I don't know, but I'm going to put a point at -2. The 0 is the easiest place to start, because we know that's 0, right? Then from left to right, all we have to do is map negative or positive. For now, we're just sketching it. Okay. So start with the 0 slopes, the horizontal tangent lines, and put 0 on your grid for every one of those. And then you figure out positive and negative slope. And lower by the x-axis. You will get really good at transferring between these two. I promise. It's kind of mind-blowing the first time you do it. Let's see if there's another one. There is a basic one. We use this a lot. Okay. What's the derivative? Sure. It's a line, right? We could graph that line if we wanted to. We can also estimate it or sketch it with this. And so there's a horizontal tangent line right here, right? That's the slope. Okay, so value to 0. Over here, the slope is positive or negative. Negative. And over here, it is positive. Okay. See how those correlate? The y-intercept is 0. The slope is 2. Now my graph sketch is not perfect. It gets the job done. Okay. Does that make a little bit more sense than that? Easier. Yeah. Well,
No.
What is the derivative at 1? The slope is 2. Right? So at x equals 1, I will have a point at 2 if I want to be perfect and exact. Okay. You know, you got 10, what's my new point? And 20, so you have 10, 20. That would put a point there. Okay. The value of the derivative that we're putting on our graph. Okay. Let's try this. Like I said, you're getting really good at this. We're going to see it a lot. It's going to aid through the rest of the year. You probably earn at least 10 points on AP exams in this. And that is like 1/3 of your free score. Okay, so. We will practice it a lot. Yeah, I pick and choose, so I'm glad you a lot here. You're probably up tonight. I'm gonna take a little bit of your work away. I'll tell you what. I could just make it due Tuesday.
Yeah. We can do all problems.
That'll be fine.
Thursday, Tuesday?
When do you want this to be due? Tomorrow, okay? Okay, so tomorrow we'll do this, but tomorrow's work will not be due until Tuesday. So I'll make that adjustment. So get working on those, let me know if you get stuck.
Only 5 to 2 is fine.